Dr. Nozatushima binti Kamaruddin, Dr. Othman bin Talib, and Professor Dr. Zanaria binti Abdul Majid. So for today's Inspem seminar, I'm going to share our ideas on the development of the mathematical creative inquiry learning model for secondary school mathematics learning. So the title of my PowerPoint presentation for today would be a creative inquiry learning, reshaping creativity in mathematics education. So this is going to be the overview of my PowerPoint presentation for today. So let's start by talking about the introduction or the background of this research study. So why is creativity and why creativity becomes the main focus in this research study? So this Malaysia Education Blueprint 2013 to 2025 specify a major transformation in producing a balanced education among Malaysian students. And one of the things that have been highlighted in this blueprint is that every student needs to master a variety of cognitive skills. And as you can see from this slide, apart from critical thinking, innovative, and problem solving, creativity is one of the elements that need to be enhanced among the students. So inspiring creativity through curriculum is the results of ongoing efforts in the 21st century educational development of worldwide change. As shown in this blueprint as well, efforts are underway to improve the quality of the students' creativity in mathematics learning in Malaysia. So the introduction of science, technology, engineering, and also mathematics, STEM education also has focuses on the development of creativity, especially in mathematics learning. So being creative will help us to become a better problem solvers in all areas of life and also work. And this creativity component could also help us to see things differently and help the student to solve the mathematical problems in different ways in mathematics learning. Past studies also shows that these creative learners could adapt their way of thinking with the flow of the creativity among them in mathematics learning. So this study adopted constructivism philosophy based on the idea that people actively construct or make their own knowledge, and that reality is determined by the experience as a learner. So basically, these creative learners could use their previous knowledge as the foundation and build out the new and creative things that they learned from previous lessons. So the principles are teachers seek and value students' point of view, and these classroom creative inquiry learning activities could challenge the students' assumptions. And this will lead the teachers to pose problems of relevance to teaching the students in doing problem solving in mathematics learning. And the theory in this education that recognizes learners to construct new and creative understandings and knowledge will integrate them with what they already know and use them with real life applications. So the learners would largely adjust their previous experience in mathematics learning with the activities, real life activities, and also challenges. However, restraining the use of creativity has become one of the biggest issues that have been faced by the mathematics educators out there. We could see that the traditional approach and also chalk and talk will contribute to a passive learning environment and also will reduce the students' creativity in mathematics classroom. And this will lead to the low of students' interests, performances, and also creativity in mathematics learning. And according to Urbanston in 2019, there was also lack of appropriate resources as the guideline for the teachers to facilitate these creative inquiry learning activities in mathematics classroom. So based on the introduction, the background of the study, and also the problem statement that I mentioned earlier, we came up with the purpose of the research study here, where we want to develop the mathematical creative inquiry learning model for secondary school mathematics learning. So the development of this model is aimed to support the formal learning in aiding students to achieve both learning needs and also learning outcome through these mathematical creative inquiry learning activities. So there are three main objectives of this research study. So the first one is to determine the needs of the development of this mathematical creative inquiry learning model, MCILM. And the second phase is aimed to design and develop the model for secondary school mathematics learning. And finally, in phase 3, the evaluation phase, it is aimed to evaluate the model for secondary school mathematics learning based on the experts' views and opinion. Okay, on this slide shows another research questions based on the three main research objectives that I mentioned earlier. And we could also see that it involved three different phases here, and also the methods and techniques that have been used in every phase to answer all these research questions. So we could see the utilization of survey questionnaire, nominal group technique, NGT, interpretive structural modeling, ISM, and also fuzzy Delphi methods. So all of these methods and techniques will be discussed again in my next slide after this. Okay, now we move on to the literature review part, which is the first one, the creativity's definition. So creativity could be defined as one of the essential components for the individual, worldwide, and also economics achievement that include all of these creative elements, which are curiosity, original ideas, imagination, personal traits, and also challenges. While Ross and also Sawyer has described the 4 P's of creativity in terms of 4 different perspectives, so which are creative person, creative process, creative product, and also creative press. So in this research study, the creative press relates the creative environment to conduct or to influence the students in mathematics learning. Okay, another definitions of creativity where it can be divided or defined in terms of 4 different components, which are fluency, flexibility, originality, and elaboration. So the definition of this creativity's idea has been widely used by a lot of researchers out there who are doing studies on creativity and also creative learning. So we could see that fluency here means the number of responses given by the students in solving the mathematical problems, while flexibility is the number of categories that have been defined in the answer while doing these problem-solving skills. Originality is the uniqueness of the answers compared to the other responses given by the other students, and elaboration is the justification that has been given by the students in solving the mathematical problems. Okay, now we move on to the second part, which is the creative learning's definitions. So there are a few models and theories that describe this creative learning idea. And one of them is the social cultural theory of creative learning that been introduced in 1999 that can be divided in terms of domain, field, and also person elements. So based on this idea, creativity will take place when a person uses his or her genuine knowledge within the domain and come up with new and creative, unique ideas, as well as they have a very good contact with the creative people. And this creative idea will be accepted by the experts on the field included in the corresponding domain. Okay, another idea that been defined by Traffinger in 1992 that relates creative learning with divergent functions, complex thinking and feeling processes, and also the involvement of the students with real life challenges. So this idea is parallel with the Vygotsky's zone of proximal development theory, where he stated that there is a gap between the learner's current state of learning and their potential with the process of teaching and also scaffolding by the teachers to bridge this gap. So we could see that the teacher's role is very important and also what we call it very significant in the students' development and also learning. But the most important part about this creative learning is that it also involves the creative thinking techniques that can be divided in terms of person, knowledge, cognitive thinking, and also problem solving. So we could see that there are a few elements like imagination, innovative, motivation, critical thinking, the use of technologies, and also real-world experiences that relates all of this with creative learning in mathematics classroom. Okay, another thing that is also important is that this creative learning is not just memorizing information or formulas. It is more towards building up new and creative knowledge and developing skills among the students by using these creative techniques. So rather than dictating how the information should be absorbed among the students, creative learning could guide them through the instruction process using creative learning methods and also activities. So it is about challenge the obvious, the conventional, and also the assumed one. And to some extent, it is about breaking out the constraint of the conventional learning approach that been used by the mathematics teachers in mathematics learning all this while. So teachers also need to be creative in the nature of teaching so that they can also meet the educational profession needs and also to improve the quality of instructional practices in mathematics learning. Okay, another model that been referred to in this research study is the inquiry model that been done by Alberta in 1990, where we could see from this slide, there are 6 main stages of reflecting on the process of inquiry. But the most important part that I really need to stress on this inquiry model is that we could see the creating process at the bottom there, where it involved the creation of new and creative products or ideas, and it can be reviewed and revised for the plan of inquiry learning. So we could see that this creative inquiry learning is very important as it will engage the students deeply with the creative learning experiences. So the more the students engage with the process, the longer they will retain the knowledge and expand their understanding towards the concept. And then they can also stimulate problem solving among the students, where they become more imaginative and also innovative, and they can cope better whilst doing the problem solving in mathematics learning. So these creative learners could also start visualizing alternative also possibilities from different perspectives in solving these problems in mathematics learning. So this will allow them to anticipate difficulties and overcome them in different ways and also creative ideas. Okay, another reason why this creative inquiry learning is also important is that it can develop critical thinking among the students, where the students can propose innovative ideas and resolutions while participating in a project or mathematical experiments in mathematics. So they will also review the progress of implementing all of this idea and adjust the process for improvement in the future. Okay, and then all of this process will lead to building up curious mindset among the students. The creative inquiry learning could spark curiosity, interest, and discussions. And this will lead the students to interesting ideas and also creative information. And last but not least, this creative inquiry learning also could build a confidence among the students, where they are more likely to apply what they have learned from the previous lessons to their daily life applications. Okay, all of the elements in the 3 models that I mentioned earlier, the system model of creativity, the creative learning model, and also the inquiry model were referred to design and develop the mathematical creative inquiry learning activities that need to be included in this mathematical creative inquiry learning model in this research study. Okay, this is the conceptual framework of this study, where it involved all the models and also theories. And we could see the 3 different phases and the techniques and methods that have been used for every phase to answer the research question in the development of this mathematical creative inquiry learning model. Okay, now we move on to the methodology part. So we utilize the design and development research, DDR, and it involves 3 different phases. The first phase is the need analysis, the design and development in phase 2, and evaluation phase in phase 3. So this design and development research is a very comprehensive research methodology that combined various methods and also techniques to develop a model. And the rationale of using this DDR approach in this study is to satisfy the objective of designing and developing the model, and at the same time to answer all the research questions in this research study. So this approach is very flexible and systematic and could be used to develop a learning model in any research study. And the choice of this DDR approach in this study is also generally because it is the most common approach used by a lot of researchers out there in developing information materials, and it also can be compatible with the purpose of developing a model. And according to Ricci and Klein, they also defined this design and development research as the systematic study of design, development, and evaluation processes with the aim of establishing an empirical basis for the creation of model that governed their development. Okay, now we're going to concentrate on every phase of this design and development research study. So for the first phase, the need analysis for the development of this mathematical creative inquiry learning model. So we use the proposed sampling as the sampling technique. And the main reason why we choose this proposed sampling as the sampling framework is because we want to focus on particular characteristics of a population that we're interested on, and also to answer the research questions. So in this case, we're looking at 120 mathematics teachers. And at the beginning of this research study, a systematic literature review, SLR, was also conducted to decide the current needs of the development of this mathematical creative inquiry learning model. And a pilot test was also done to another 40 mathematics teachers to look at the reliability of the instrument. And based on the Cronbach alpha value here, we could see that the instrument is reliable and can also be used for the actual research study. In order to determine the justification and strengthen the needs of the development of this model, we conducted a survey questionnaire to these 120 mathematics teachers, and reviewing the literature indicates that the creative learning is creative in the sense that it requires making creative and new knowledge more meaningful, more interacting, and also more engaging to the students in mathematics learning. And in addition to that, educators were able to understand various questions and also answer terms like enhancing creativity, creative learning, and assessing the mathematical creative inquiry learning activities in mathematics classroom. So based on the findings of this phase on the mathematics teachers' acceptance to use this mathematical creative inquiry learning model, the overall result concluded that the mathematics teachers were highly accepted this model to be developed as a creative learning model in facilitating students' learning needs. And they were also intended to incorporate all of the mathematical creative inquiry learning activities that need to be included in this model into the formal mathematics learning. And we could see that the overall finding in phase 1 justify the needs to develop this mathematical creative inquiry learning model for secondary school mathematics learning. Okay, we could also see that all of these teachers that have been involved also agreed with all the creative learning elements in mathematics that can be divided in terms of percent, process, product, and also price. So all of these creative learning elements will be used to design and develop the mathematical creative inquiry learning activities in the second phase of this model. And then another part that is also important here is that the teachers also agreed and accepted to use these mathematical creative inquiry activities in the developed model and incorporate that into the formal mathematics syllabus. So from this slide, we could see that 98.3% of them agreed and accepted to use this model as it can be used in real world experiences and also to improve the critical thinking of the students in mathematics learning. Okay, now we move on to the second phase, which is the design and development of this mathematical creative inquiry learning model. So for this phase, there are two stages altogether. So in designing the model, we actually utilize the nominal group technique, NGT, to get the agreement between the 12 mathematics experts on the selection of the mathematical creative inquiry activities that need to be included in this developed model. So this nominal group technique is a group process that involves identifying problems, generating solutions, and also decision making. So this group of experts work together to make a decision quickly by using a vote. The difference here is that every expert of the group will share and also explain their view of the situation. And then is there any duplicate solution? It will be removed from the list. And the member will also rank the remaining solutions of the creative inquiry activities that have been selected from first to second and third and so on. For the selection of the expert chosen in this stage, it was based on their experiences in mathematics education field, theoretically and also practically. And the priority is for the mathematics experts with over 5 years of mathematics teaching experiences. Prior to the expert selection process, these experts were given a letter of appointment at the beginning of the research study. And then all of these experts should be able to learn the mathematics lesson based on the mathematics syllabus in secondary school as well. Okay, the experts must also have involvement as the mathematics educators who are responsible for the curriculum development and also review. So these experts in this research study are very skillful in the fields of mathematics education, curriculum, and also instruction. So in this nominal group technique, there are 5 steps altogether. So the first one is the introduction and the explanation, where we welcome all of these experts and explain to them the purpose and procedures of this nominal group technique. And then we also have the silent generation of idea, where every expert was given time to generate the ideas that come out to their mind when considering the question. So during this period, we ask the expert not to consult or discuss the ideas with other experts that are involved in this research study. And then this process will last around 10 minutes. And then we also invite all of these experts to share the ideas that they have generated. This is very important for the expert to get the opportunity to make an equal contribution, and they can also provide a written record of all of the ideas generated by them. And then this stage took around 30 minutes to finish up. And then we have the group discussion, where the experts were invited to seek for verbal explanation of further details about any of the ideas that the other experts have produced that might not be clear to them. So this is also crucial to ensure the process is done as neutral as possible to avoid any judgment and also criticism by other experts. So the group may suggest new elements for discussion and combined all of the creative inquiry activities that have been developed and selected into categories or domains, but no ideas should be eliminated at this point. And this stage lasted around 45 minutes. And finally is the voting and ranking session, where it involves ranking the ideas in relation to the original question. So following the voting and ranking process, immediate results in response to the question is also available to the experts. So the meeting could conclude having reached a specific outcome and also develop the mathematical creative inquiry learning activities that need to be included in this model. Okay, due to the COVID-19 pandemic, we have to conduct the data collection online. And from this slide, we could see that some of the photos taken during this nominal group technique, where we use the Zoom conference meeting in conducting this nominal group technique process with all of these 12 mathematics experts. And this slide shows another 27 learning activities that have been agreed and accepted by the mathematics experts. And we could also see the ranking based on the preference from the experts. And all of these learning activities will be analyzed using the Concept Star software in the next stage. Okay, this is the second part, the second stage of the second phase of the development of this mathematical creative inquiry learning model, where we use the interpretive structural modeling, ISM. And this is a very important stage of this research study where we want to develop the model and also to look at the relationship from one learning activity to another. Like I mentioned before, a Concept Star software was used to analyze the data in this stage. So as you can see here, these are the relationship of all the mathematical creative inquiry learning activities that have been analyzed using this Concept Star software. And all of the learning activities has been divided in terms of 6 main domains, which are ideate, inquire, explore, challenge, collaborate, and also reflect, where all of this domain has been accepted and also agreed by the mathematics experts in this stage of the development of this model. Okay, the next process is to construct the structural self-interaction matrix, SSIM, to get the reachability matrix for every learning activities that been developed in this phase. So this is very important, where we look at the driving power and also the dependence power for every learning activities. And we could also categorize them into 4 different clusters classification, which are the independent, the linkage, autonomous, and also dependent activities. So the classification of these learning activities would decide which learning activities needed to be performed first and which learning activities should be combined to help the students to meet their mathematics learning needs. And the findings of this phase of this research study is a recommendation on how the model could be implemented and also developed through a variety of mathematical creative inquiry learning activities, both formal and informal, to assist the students in achieving their mathematics learning goals. Okay, now we move on to the final phase, which is evaluation phase in phase 3. So for this phase 3, the evaluation phase, we use the fuzzy Delphi method to get the consensus between the mathematics experts on the evaluation of the model. So this fuzzy Delphi method is used to improve the time consumption and also to solve the fuzziness of common understanding in experts' opinions and also views. So this method was based on the group thinking of the qualified experts that ensures the validity of the collected information. Okay, so there are many advantages of conducting this fuzzy Delphi method, and one of them is to save time on the questionnaire. And then we can also save costs in this research study, where we could reduce the total number of surveys. And then we could also see that the questionnaires will increase the recovery rate compared to the old Delphi technique. And you also make sure that the expert can fully express their opinions, their views to assure the completeness and consistency of the opinions and the views of them throughout the studies. We also make sure that we need to take into account the ambiguity that cannot be avoided during this study. So this method does not misinterpret any original experts' views and opinions, and also can give them the real reactions and views towards the items. Okay, for this fuzzy Delphi method, we included another 25 mathematics teachers where we use the Microsoft Excel based on the fuzzy Delphi method as the tool to analyze the data. Okay, so on this slide shows the procedures or step in conducting this fuzzy Delphi method. So the first one is the fuzzy scale selection. So this is the process of converting all of the Likert scales into the fuzzy scales. And this is essential to determine the mean fuzzy value M1, M2, and also M3. And then the third step is to obtain the threshold value D. And in order for all the items to be accepted in this phase, we must make sure that these two criteria must be fulfilled. So the first one is that the threshold value, the average, must be equivalent or less than 0.2. And it will also have a more than 75% consensus between all of the experts that have been involved in this phase. And then finally, we have the defalsification process where we want to determine the ranking or the scores for every item in this questionnaire. Okay, so this is the Microsoft Excel based on the fuzzy Delphi method that been introduced by one of the lecturers from UPSI. His name is Dr. Muhammad Ridwan. So he is one of the experts in doing design and development research study here in Malaysia. So based on the results, we could see that the mathematics experts agreed with all of the items of the evaluation phase. That includes their views and opinions on the suitability of the arrangement of the mathematical creative inquiry learning activities, the suitability of the main domains, and also the cluster classification that have been developed. And finally, they also agreed with the overall usability of this mathematical creative inquiry learning model for mathematics learning. In addition to that, a content validation was also conducted. It was carried out to determine the validity of these mathematical creative inquiry learning activities and also elements that have been developed in this second phase. Okay, so this is the final model of mathematical creative inquiry learning that been developed using this design and development research study. So we could see that there are 27 different mathematical creative inquiry learning activities, and we could also see the relationship from one learning activity to another. And all of these learning activities has been divided in terms of 6 main domains, which are ideate, inquire, explore, challenge, collaborate, and also reflect. And all of this has been agreed and accepted by the mathematics experts in the second phase. So, so as you can see, this developed model could facilitate the mathematics teachers to use all of these creative inquiry learning activities that have been developed in mathematics learning. And we could also see that these developed models could offer a different way to look at creative inquiry learning and the essential elements that make this creative inquiry learning happen in the mathematics classroom. As you can see, different models are best suited to different learning outcomes and also different students. And using this theory as lenses in this model, the mathematics teachers could understand and describe their roles of the instructors, the teachers, their role as the facilitators, the role of the students as the learners, and how this creative inquiry learning happens in different ways, especially in mathematical creative inquiry learning. This model also could provide the context of learning, underlying motivation among the students, and methods of teaching that have implication for the teachers to design and deliver instruction in mathematics. And we're actually in the process of getting the copyright for this model, because as you can see here, this developed model could influence creativity and innovation among the students, while it focuses on student-centered learning. And at the same time, it can also improve the engagement and collaboration among the students while doing the meaningful and hands-on activities in mathematics learning. Okay, for the significance of this research study, so this creative inquiry learning model is one of the best alternatives for schools, especially in mathematics learning. So to be able to produce effective creative inquiry learning in mathematics, the teachers must also innovate and creative to develop teaching materials that can be used as the medias for the students, so that the learning become more useful and also creative in mathematics subjects. So this developed model is also suitable to be used during the online session to facilitate these mathematical creative inquiry learning activities among the students. And we could also see that this developed model could challenge new problems, enhance creativity, imagination, critical thinking, and also motivation among the students while solving the mathematical problems. So it is hoped this developed mathematical creative inquiry learning model will have an insight and advance the quality of creative mathematics learning that can be related to practical use, and also to develop the foundation of our mathematics curriculum design in the future. So these are some of the publications we have based on this research study. Okay, these are the awards and also achievements that we receive based on the idea of this creative inquiry learning. And also the presentation that we took part in the seminars and also conferences for the past 5 semesters. Okay, I also shows and also share some of my supervisory committee members' certificates during the participation. Okay, so I guess these are some of the humble sharing and also experiences while conducting this research study. And I believe that the process of this doing this research study is not an easy journey, and it's quite challenging, especially it's been conducted during the COVID-19 pandemic and also during the lockdown. And I would like to take this opportunity to thank all of my supervisory committee members. There are Dr. Nuzatu Shimal binti Kamarudin, Dr. Osman bin Talib, Professor Dr. Zanaria binti Abdul Majid, and also to all other lecturers for their support and also guidance over the past 2 years in this research study. And I'm particularly grateful for their detailed advice, motivation, help, and also encouragement on how to conduct this research study and how to develop this mathematical creative inquiry learning model. My sincere thanks also goes to the Inspem staff, Inspem members, and also my colleagues for helping me out by providing valuable suggestions, in particular guiding me through during my study here at Inspem for the past 5 semesters. So before I end my presentation, I would like to share this creative quote done by Sir Albert Einstein, where he stated that the creative principle of science reside in mathematics. So as you can see, creativity is a very important skill, as it will make our life more interesting and also fulfilling. This creative element has this amazing power to give you renewed enthusiasm and also energy, even in the most difficult situations. So this creative inquiry learning, on the other hand, will allow the students to view and solve the mathematical problems differently, creatively, with the use of innovation and also technology. And as you can see, the creative inquiry learning could also open the curious mind among the students and enhance the students' interest in learning this subject. So it is hoped that these creative inquiry learning activities that have been developed in this model should be encouraged among the students here in Malaysia so that they can explore different things, ideas, can take risks, and also use their imagination to solve the problems in mathematics learning. So these are the references that I used for this presentation. So I guess that's all my sharing. Thank you very much for listening. So I'll pass to Muhammad Reza again.
Okay, terima kasih Haniza di atas perkongsian dan pembentangan tersebut. Mungkin dalam tempoh masa yang ini kita buka untuk sekiranya ada soal jawab ataupun pertanyaan daripada peserta. Is there any Q&A you can ask Puan Haniza? We open for Q&A. Prof, ada persoalan?
Ya. Terima kasih Dr. Rohaisa dan ya, congratulations Puan Haniza. You have a very good work.
Thank you.
Yeah, and yeah, keep it this way. Okay. Yeah. I remember Frederick Gauss when he was 10 years old. Yeah, and what he had done inspired me during my whole life. What is that? It is about teaching mathematics. Yeah. Yeah. Teaching mathematics is not to direct student to learn mathematics. No, not to learn mathematics, but to learn how to produce mathematics. Beda ya? Ya, beda. Antara belajar matematik dan belajar membuat mathematics. Nah, kalau di Malaysia, according to your experience, Puan Haniza, which one is in practice? Yeah. Guiding student to learn mathematics or guiding student to learn how to produce mathematics? Which one?
Okay, thank you for the question. So basically, this mathematics learning is much more than calculating, counting, and finding solutions of mathematical problems. So encouraging these students to think creatively, okay, to learn mathematics has a multitude of benefits to them for their personal, also healthy development in mathematics learning. So most school curriculums today shouldn't focus on just the fact memorization, data, or repetition from the textbooks. So as you can see, this mathematics learning, on the other hand, must encourage children to explore different ideas, to take the risk and use their imagination to solve anything that they learned that relate to mathematics. And another thing that we have to make sure that, like I've mentioned before, the creative learning in mathematics will encourage the children to explore different ideas and also take risks while doing activities that involve hypothetical questions, abstract ideation, imaginative play, projects, and also experiment in doing this mathematics learning. So we need to help the students to find their interest by incorporating all of the multiple disciplines with mathematics learning. For example, we incorporate the mathematical creative inquiry activities that I mentioned before into other subjects. For instance, physics, music, or arts, where all these students can discover new interesting ideas that related to mathematics. So this will make the mathematics learning more interesting and engaging to the students. So I think I answer your question, yeah, Doctor.
Yeah. You are on the right track. Yeah, but I suggest not only to you but to all Malaysian teachers of mathematics. Yeah, or to the government of Malaysia. Yeah, go beyond guiding how to learn mathematics. Yeah, I mentioned about Frederick Gauss. Yeah. At age 10, he had invented mathematics. Age 10. Yeah. He his creativity, his innovative mind, uh, brought him to make a formula how to sum up the number 1, 2, 3, 4 until 100. Just only in several seconds. Yeah. And that's about Gauss. And in modern era, if you read the biography of Terence Tao, when he was 9 years old, he was invited by Erdos, because this boy is very strong in not only in doing mathematics, but in inventing something in mathematics. So I think Malaysia can do it. Go beyond learning mathematics. Lifelong learning is good, but not good enough. Lifelong producing mathematics is enough. And just for your information, I just established in Indonesia what I call CQI TLP Research Group. CQI TLP stands for Continuous Quality Improvement of Teaching and Learning Process. I direct the research group, consisting of all mathematics teachers in Indonesia. I would like to invite you to join that group. We have a WhatsApp group, and you can search in YouTube. Just click my name, and inshallah you will find that. Please go beyond learning. And reach learning to produce mathematics, learning to produce statistics, learning to produce physics, learning to produce history. We have to learn history, but the most important thing is we have to make our own history. Thank you. Puan Hanisa.
Thank you very much.
Thank you, Dr. Raizat.
Thank you, Prof. Soalan saya mungkin model ni boleh kita gunakan pada subjek lain juga.
Yeah, betul, Doctor. Because now we're in the process of getting the copyright. So we could see here that this mathematical creative inquiry learning model could also be incorporated to other fields, like what Dr. Muhammad Raizat said. It can be also done to other subjects. But the most important thing about these creative inquiry learning activities is that it is quite general, where it can be used to all other students, not for the secondary level as well, but for the primary or maybe for the, what we call it, higher level learners. So yeah. So because in this research study, we're actually concentrating on the mathematics learning, but it can also be adapted to other subjects as well.
Yeah, you need to copyright.
I need to,
before.
right? Yeah, you're in the process.
Another question, is it this teacher in mathematics in Malaysia, is it creative more rather than other country?
Again, Doctor?
Uh, the teachers in mathematics teachers in Malaysia more creative rather than are you study the other country also, the Asian country also, or Asian?
Okay, from my experience as a mathematics teacher, I've been teaching mathematics at St. John's Institution for 10 years. So I can see one of the issues and also problems that have been faced by all of these mathematics teachers was to conduct a creative mathematics learning. So this is due to the time constraint and also where we could say that the students are more interested to what we call it, to easy steps rather than to know the creative methods of solving the mathematical problems. So another thing that is also important in this, what we call it, creative learning, we need to have a very concrete motivation for the students to adapt all of these creative inquiry learning activities in mathematics learning, where they can relate and also connect what they have learned in real life. So I believe that the school and also government, especially the Ministry of Education, need to help all of these teachers to give some funds and also support them to facilitate these learning activities. And we could also help them to do like research that use creativity and tell them why is it crucial in the mathematics learning. So I believe that we could also adapt this creative learning in mathematics learning in Malaysia if we're given the opportunity and also given sometimes to what we call it, teach the student in a specific way. So we could also show all of these teachers how the creativity could help the students in finding their future careers and also jobs. And we could also, as a teacher, we could also show the students a problem that we could solve in the classroom by being creative.
Yeah, thank you.
Okay, terima kasih. Thank you so much for inviting Dr. dan Inspem.
Ya, terima kasih Puan di atas perkongsian yang sangat menarik ini. Mungkin boleh dikembangkan dan Prof Maman juga telah offer untuk join group di sana ya.
Yeah, I'm interested. Yeah, I really interested to join, Prof.
Ya. Mungkin tempoh hari Puan juga telah menjadi moderator kepada Prof Reza itu, mungkin boleh communicate juga untuk mengembangkan lagi kajian ini ke Jepun dan sebagainya lagi, insyaAllah. Okay. Okay, terima kasih pada Puan dan pada Prof dan semua yang hadir pada petang ini. InsyaAllah kita jumpa lagi pada siri akan datang. Jumpa lagi. Assalamualaikum warahmatullahi wabarakatuh. Bye-bye.